So let's start with the Aiolos and Celia models, which are models basically most for the electricity demand. They are good with electricity demand with long history and so on, and they are based on a linear regression, and they find dependencies between historical production or load and different weather. Different input data is historical consumption. You have a calendar, so you define day types so that you can separate weekends from weekdays, for example, and also much more than that. Then you have also the weather forecast and observations. And then they are adaptive as well, so they are, so you can make look at the most brief observations or consumption from load data so that you can adjust your series to the right level so that it won't be on too low or too high level. And also in this you have the real-time correction so that you have possibility to for your intraday forecast we can use real-time correction as well. Yes, so they use multiple linear regression, meaning that they have multiple variables within the linear regression. And I'm going to tell how the models work using the basic steps, these basic 5 steps. So social load, weather dependent load, stochastic load, the adaptation, and the final forecast. So first I'm gonna try to define the nomenclature of this. So we have one, we have day type, and that's cluster dates with similar social behavior, meaning you differentiate between weekdays and weekends, for example. And then we have our reference period, which is the search window for when you're looking at the different day types to find the different social patterns. And then our base period is when we are looking at the weather dependency, and then adaptation is nearest to our forecast stars when you were looking if we want to adjust to the latest load input. So let's start here with the social load. So here in this example here we have our forecast start here today, and we want to make a 3-day forecast. So the first thing that we want to do really, if we have also history for several years backwards, so for 2011, 12, 13, 14, 15 up to 16, and we want to make a 3-day forecast, and then we have this historical data, but we have to know what it represents. So the first thing we want to do is to define our day types. So this is our social load, because different day types have different day type patterns. So you have for weekdays, we have one pattern which depends because you have one social behavior when you're going to work, industry is rolling, services are rolling and so on, stores are open, and Saturdays you have one, and Sundays you have another maybe, and then during holidays such as Easter you might have a total different kind of social behavior. And this you can define for whatever holiday you want, so you can have it for national holidays, for if you have Patreon holidays and so on. So whenever there's some change in the social behavior that leads to a change in the consumption or the load profile, it's good to define this in the day type. And when you define different day types, you add them up in the day type calendar, And this date type calendar uses a three-step way to do it. So first you define a date type rule saying, for example, that each each 6th of December is a national holiday, and then you say that that's the Finnish National Day, and then you define a date type to that, and then you define that date, or you set that date type to your date type calendar. I won't go into a demo at this stage because there's also an Educandi video that shows how you set up and this date type calendar and how you use it. So I recommend you to watch that one. But when you have defined your date types and added them into your date type calendar and assigned your date type calendar to your series, then you have your first step. So now you have categorized and differentiated between your load and your historical data. So now we know when there's a weekday, we know when it's Saturday, Sunday, and when there's Easter. So here in this example, the yellow dots are Easter, and then we have Sunday on the red dots, Saturday on the blue, and weekday on the gray one. But then we want to also, you need to define what of these you want to look at. Do you want to, if you look at everyone, then you look at very much data. But you might, in the reference period, you then defined in the window which you want to look at this. So here you also get the seasonal dependency. So this one you want to set not too narrow, because if you set it too narrow, you get a too narrow window, which means that, for example, for this kind of holiday like Easter, which is only a few days in the year, it could happen that it's also on different dates each year. So if you're unlucky and you don't only have, say, data for 2 years back, and the Easter dates is really late this year, then you have a narrow reference. It might be that the Easter date type falls outside of the reference period. In that case, you have a second choice in the date type as well. So you could, example, be looking on a Sunday date type instead. But it's always better to have the same date type to find out how it usually looks during that particular holiday. And in this example, we're looking back for 2.5 weeks and ahead for 2.5 weeks. So that's roughly a little bit over a month of data that you're looking at each year for each year here. So this is when you're then defining your social load for the date type, different date type patterns. And then after this, we're looking at the base period. So here you're looking at the weather-dependent load. This is where you differentiate also between the Celia model and the Aiolos model. So with the Celia model, you start from the forecast start date and you start looking backwards immediately after that. But in the base period for Aiolos, you're jumping up 1 year and looking at the previous year instead for those days. And if the case is that the Celia base period is missing, data for this period, it will automatically also jump up to the next year and act like a YOLOS model. And what are the parameters that we are looking at then? So we are looking at temperature for our T and also for the previous hour and for 2 hours earlier. Then we're looking at global radiation in the same way for now, relative to forecast starting now, and then for the previous hour and 2 hours earlier. And then we're also looking at the chill factor, which is calculated from temperature and wind, and those are looked at as moving averages for last 6, 12, 24 and 48 hours. So these are the weather parameters that we're looking at when we're using the YOLOS and Celia models. And then the stochastic load. So what this is stochastic means it's an unexpected load, something out of the ordinary happens. So for this example, it was a snowstorm in Gothenburg which left parts of the city in blackout, meaning that the forecasted load and the actual loadout data differs very much. And when this happens, it's good to know that this was because of something that's out of the ordinary, because this is not representable for these day types or these weather otherwise. So you would like, for example, what you would want to do so that the model does not take it into account when it's forecasting in the future. So what you would like to do here is that you would like to somehow mark this data. So one way of doing this is to mark this as a special day type in the day type calendar, or the other way of doing it, or my preferred way, is to just mark this area here and just delete this load data so that the model won't use it as references in any case, because this could be for, especially if this occurs during holidays as Easter or Christmas, it has a very big impact on the forecast. So it's better to have representable data than this kind of data that is not really representative for what should happen, because you shouldn't calculate with that it should be a blackout. So yes, and then let's move forward. So the adaption. So that what the adaption does is that it looks at a period which is as close as possible to the forecast start, and then it makes a new forecast, and then you look at the reforecasted values with the load data, and if they correlate, you could use that to adjust the forecast upwards and in level, or also you could stretch it, the forecast as well, so the amplitudes you could stretch as well. Yes. So to show you an example of this, here we have historical data for a while back, and then if you would make a forecast based on this here, you would end up with a forecast here that would be somewhere in the middle here. But by doing a test forecast, you have a search window, and then you have the length here. So the length here tells you how long the test forecast should be. So it could be from here to here, for example, or it could be very narrow from here to here. Then the adjustment would be greater, and the longer it is, then the smaller the adjustment would be, but it would be slower. But yeah, and the forward tells you how much forward it should make the adjustment for the forecast. So if you would make an adaptation, for example, for this period here, what would happen is that you would actually also get a linear correction for your forecast, so that the level of your forecast would be much higher in comparison to not having the adaptation. And this adaptation lets you to move to the right levels if you have for example, during different seasons and so on, that you can adapt to new levels and so on. Yeah. So short summary then for our Celia and Aiolos models. We have date types, the cluster dates, and the date type calendars. So you divide your different days into different date types, and you differentiate between different social behavior. And then you have the reference period marked here, which is your search window for the date types to find different social patterns. And then you have your base period. So you have the Celia base period directly after the forecast start, and the base period for Aiolos is here year before the forecast start, where you look at the weather dependency. And then the adaptation for when you want to adjust your forecast to the right level, you look at the most recent data, longer or shorter, depending on how fast or how big adaptations you want to make. So in general, this would mean that the Celia 0 years, meaning that you're looking at only here backwards, so you're looking straight after the forecast in the same year, is good for new series that have very little historical data. So then you probably want to use a Celia model, since you have the base period right after. And if you have a time series that is more stable and does not really change that much, you would use probably Aiolos models with several years. So here you can make different settings for how fast you want the model to respond, and so on. So the final forecast for the models for output power would be, you have your adaptation, then you have your weather dependency, and we have our social dependency. And if we go into details, we can see here for the weather dependency we have the temperature for hour 0, for last hour, and for the previous 2 hours. Same for global radiation, and then moving average for the chill factor. So for moving average for 6, 12, 24, 48 hours. And these are calculated from temperature and wind. It's also possible to use real-time correction. Always when you use this, you need to be sure that you have good data that's coming in, so that because if you only get, for example, part of the load consumption in intraday or real-time data, then what would happen is that the real-time correction would actually correct the forecast so that it would be much lower than the actual load would be, as an example. And that's a typical example of if you do bad in data for real-time. What it does is that it looks at the previous or the latest hour, available production hour, and then it uses linear converging to make the correction to the forecast. The adjustment period can be set to 1 to 23 hours. And yes, it might be good to maybe not set it for too long, but maybe looking at more shorter terms instead. We also have hold off quarantine, meaning that you can, if you want to, you can import data that you're not certain that they are good, but you want to import it maybe immediately instead, and then you can set your hold off so that you can say, for example, that the latest 2 days is probably bad data, so I don't want the model to look at the newest or the latest day, for example. And if you use real-time correction, the hold off must be 0. So if you want to set up multiple models for a series, one with real-time correction, one without, you can, and you're not sure how good the data is, you can use the hold off function on one, and the other one you can use the real-time correction on, and then you can evaluate the forecasting result and follow up afterwards to see how it went. Yes, and then I thought that I would show you also in the program a little bit where we make these settings. So if we start here typically under home here, so when we're working with our models and the model settings, we're making changes in the configuration, so we're going to the config tab here. And then there is 2 ways of finding the properties for the models. You can go, you have the grid here, so here you can choose the model window, then you have all your different models. And this, if you have many different or a separate model for each series, this is a good way to use the grid to make changes to a lot of the models at the same time if you're making the same kind of changes. So then you can work in the grid. And the one you're standing on, then you see the properties windows here is for the one that is blue here in the grid. Also, if you go in the forecast series, so you can choose one forecast series. So for example, we have area consumption profile. So what you can do here is to right click and find in grid, and then you find your series here, and you find it in the grid here, and then you have the properties for the forecast series in the gray box here. When you're here, you have under models here, you can see all the different models that are connected to this series. And to look at the properties for the model that is connected to the series, you can push the blue arrow here. And then we're here in the model properties window. So here you're choosing your model type, you're setting your quarantine. In the calendar settings, you are choosing which calendar you want to look at. If you have used calendar legacy, then you are looking at this daytype calendar file here, which is an old legacy file, and you can use the legacy program to make changes to that. And this one, sommer.dat, is the daylight savings time file, if you have that. But you can also have the new daytype calendar, which is also here, to use, and to use that, you just here select use calendar, and then you get the message that the new daytype calendar only works with the 2.0 models, which means that we need to first change the Aiolos model to an Aiolos 2.0 model. Then we can choose this, and now we're using the daytype calendar that is inside Aiolos Forecast Studio. And here you can choose your different calendars then after, if you have different regions or so on. So here you can have multiple calendars and choose which ones you want to look at in this model. And then we have the reference period for Aiolos here. So here you're looking at how many days per year you want to look at, and how many years back you want to search for different daytype patterns. Then we have our base period settings here, and here you can choose how long your base period you want to be, and you can choose also the settings for the F value or the F test, the statistical F test. You can also choose max model size, which means that you're telling how much of the parameters should be included at maximum, meaning the temperature at hour 0, the previous hour, and so on, these parameters. So in this case you can have max 5 parameters, but it needs to meet also the statistical test, so you will only have parameters that are statistically proven and that are good. So if they are not within the accepted range, then they will be tossed out and they will not be used. So even if you have max 5, it might be that the model chooses to only use 2 parameters, so that you that are good. And then you can also choose to ignore wind and ignore global radiation, so that if you click these, then you only look at temperature as a factor. And here you have the settings for the adaptation period. You can choose to use it or not. You can separate weekdays from weekends if you wish to. You have the length for the adaptation period when you're making the test forecast. The longer it makes, then it won't make really quick or too quick or too big jumps in the level because of something in the history that was very unusual. And then forward just tells how long it should make the adaptation, and the search window is for how long back you're looking at. It's accepted to look for data for the this adaptation period. And then tolerance gives how much you're willing to let the model or the adaptation adjust your forecast. And the correlation tells that it needs to correlate this much to actually be used. If it's not representable, the adaptation won't be used. So it needs to be similar to the historical data. Then we have the real-time corrections, use or not use, and then adjust period. So here this you can set from 1 to 23. But caution might be needed for a longer period, and maybe start with some lower numbers. Then we also have data requirements, so you can check for data and get warnings if you're missing any sort of data. So max hours to load data, meaning this is 24 hours back. So here you're allowing the last 24 hours of load data to be missing, but if you're missing more than 24 hours, then you will get a warning. And here is the same thing with weather observations. And here you're looking at max hours to forecast start. So this is telling me that the forecast must start within 24 hours before the forecast start. Otherwise, I'll get a warning. So if the forecast is older than 24 hours, then I will get a warning, and it will tell me that I'm missing a forecast. And forecast end tells me that I need to have this much available data in the forecast that I'm using. So here, because otherwise it will start using a normal weather. So you will get a warning as well if the forecast, the latest forecast, doesn't cover your entire forecasting period. Yes, and then you have also some more load data checks for the IOLOS and Celia 2.0 models. So you have the max relative data, which is the relative data, so that you don't have these big jumps in the historical file. So if you have a relative data that is from one value to the next value is very big, the jump, then you can say to the model that it should ignore this period. And here in the max hours to ignore, you tell the model how much forward you should ignore, or how much you should ignore. And this is for the mean relative difference. So this is the max mean relative difference in the load data. So this is to see that you have good historical data in your file as well. And if you have these spikes, for example, you can tell the model to to not take them into account in the iOS 2.0. Okay, I think that this was that for this, and now I will continue with the PowerPoint presentation.